Okay, welcome to lesson 2 on analyzing statistics, and here we're going to talk about, last lesson we talked about measures of central tendency. Here we're going to talk about measures of spread. So we're going to do this, and I'm just going to go through the slideshow, talk through the things that are really important. Some stuff that we're going to do here is really just to expose you to some of these ideas, but there are multiple ways to do it. Please note that like all of the calculations we're going to do in this class will be done with technology. So we'll show you how to do it by hand just so we understand the calculations, but we are going to use technology. So there's another video that goes along with this that's just going to actually walk you through how to do it with technology in Fathom. Okay, so today's measures of spread. So as a warm-up, we want to give an example of two data sets that have the same mean and median, but the histograms look completely different. The point of this is to get an idea of what it would look like to have the same average and middle point, but that doesn't tell you the whole story. We need some more information. So if you can do that, then that's a good start. Learning targets we're going to talk about today: measures of spread, range, and IQR. So the first two measures of spread, they're all measures of range. The first one's a regular range, and the second one is interquartile range. I know that range and interquartile range give me information about how a data set is spread out. I can calculate each measure with technology and with a small number of points by hand. The technology is really what we want to focus on. A second learning target we're going to learn today is measures of spread, standard deviation. And so I know that standard deviation gives me information about how a data set is spread out. I can interpret it with technology and calculate it for a small number of data points. And we're just going to walk through the example there. And we did that in actually the normal distribution unit. We did that with a spreadsheet. I know that 68% of the data lies within one standard deviation for normally distributed data. This really just helps you understand what standard deviation means for non-normally distributed data. This is not always the case, 68% to 95, 99.7, but it does give us kind of a ballpark with what standard deviation means. So spread, range, interquartile range, and standard deviation are considered to be measures of spread due to how they indicate how widely the data are dispersed. Not looking at mean and median, this tells you how spread out the data is. Why worry about the spread? So you can see two histograms for a shipment of car parts, one from Honda, one from Mitsubishi. You can see that the average and the median are both 5 in either case, but that doesn't tell you the whole story. Honda frequently gets 5, and very rarely they'll get 7 or 3. Mitsubishi will get 5, but they're just as likely to get 4 or 6 as well, and they could actually go from 2 to 8. So range, interquartile range, and standard deviation just tell you more. Range is just the difference from the max and the min, so it's actually really easy to calculate. It can be very misleading though, because an outlier can spread out the range very, very easily. Smaller the range, the more consistent the data values are. So if the range is small, the more closer together points are. So for example, the range is 7 minus 3, which is just 4. So the first one has a range of 4. The second one has a range of 6. It varies by 6 days. So it tells you a little bit more about the picture. It tells you more about the story. To talk about interquartile range, we actually have to talk about percentiles. This is a formula for percentiles. It just means remember that for percentiles, that's the percentage of data that's less than you. To actually find out what point is at the percentile, which data value, what we can do is we can actually use this little formula here. P is the percent that you're higher than, so if you're in the 75th percentile, you just put 75 over 100. And N is the total number of data values. This doesn't give you the percentile, the percentage that it gives you the rank number. So to see how it works, we have to play with it. But this is a formula that kind of tells us what we're looking at. Okay. What are quartiles? Quartiles represent the points at the 25th, 50th, and 75th percentile. The 50th percentile is the median. That's the middle value. Q1 and Q3 are actually the medians of the first half and the second half. The interquartile range is the range of Q1 to Q3. So the middle 50% of the data, that's how spread out it is. So if you look at, this is a really good way to say it, lowest datum, highest datum. I didn't even know that was the singular for data point. I just always say data point. Lowest datum, highest datum. That's interesting. But the middle 50% of the data, so 25 to 75, how spread out they are is the interquartile range. You can see how it's a little bit different. Still tells you how spread out something is, but it kind of ignores the outliers. All right, so an example, you keep track of waiting time in minutes at two different restaurants. Find the quartile values, Q1, Q2, and Q3, and calculate the interquartile range of both restaurants to compare the waiting times. So the two restaurants are Super Burger and Champs, the two restaurants on Highway 89 there. I think it's 89, on the way up to the Dufferin Museum. And so Super Burger, these are just waiting times. Quarter one, if we take 25th percentile, since we have 20 different data points, like we can take 25th percent of 21, so we get 5.25. All this tells us is that we're actually right in the middle of the 5th and the 6th data point. So right halfway. The 0.25 more scientifically can be used, but really, like, we're just looking at, all we care about is right in the middle of the 5th and the 6th. Okay, it just gives you a rough idea of where the Q1 is. Okay, the average of 3.7 and 5.2 is 4.45 is Q1. Q3 is similarly found, 75% of 21, so 20 plus 1. This just kind of keeps in mind like the rounding up. It's just like an algebraic formula that works to give you the middle point. So right between the 15th and the 16th data point, and that's just 8.9, 8.9. So right in the middle of 8.9, 8.9 is 8.9. So Q3 is 8.9. So with Q3 being 8.9 and Q1 being 4.45, the interquartile range, so how spread out the middle 50% are, is 4.55 minutes. Okay. The median is just the middle of 10 and 11. With 20 points, you got the middle of 10 and 11, which is 7.35. Okay. Fathom actually calculate Q1, Q3, and the median and IQR for us. And for a demonstration on this, just watch the next video in this folder. So Super Burger, like Champs, you can actually compare it to it. The interquartile range is 2.25 versus 4.55. So interquartile range for Champs is a lot smaller. So they're a little bit more consistent in the middle 50%. This does the exact same thing, but I find it helps like visually to see the median is right in the middle of all the data. If you split this part in half, like this is the middle of the middle, so you've got 5 points here, 5 points here, 5 points here, and 5 points here. They're a really helpful way to see it. If you don't have an even number on both sides, like you have an odd number, it is that number. So like it's the same way as calculating the median. You'd still split it in half. If you have an odd number in the middle, so you actually have a median number in the middle, we still look at the first half, and whatever it is, it's just like calculating median. Okay. Notice that the Q1 and Q2 and Q3 are the average of those middle points. So this is the same way we can calculate it just without the formula. So you can do it visually. I find it helps to do it visually for me personally. And so I really just find the middle points that way. Okay. I like it too because it really just shows the middle 50% of the data, the middle 10 pieces of data really. Okay. The summary is the key point because we actually don't really care about how to calculate these by hand so much. We're going to get Fathom to do that for us. So the summary is the important part. Just to summarize it, we've got the medians for both. Since the median waiting time for Champs is lower, it appears to be faster. So Champs doesn't make people wait as long. Also, the IQR for Champs is lower, indicating the waiting times are more consistent at Champs. So not only is it faster, it's also more consistent. The middle 50% of the waiting times are only 2.25 minutes apart, versus the middle 50% of the waiting times are 4.45 minutes apart. And that's exactly how we read it. We don't just say, oh, the IQR is this. We say the middle 50%. Super burger times are more spread out. Okay? So that's what we refer to as range or interquartile range. Okay? And stay tuned to the next video for discussion on standard deviation.